In this video, we are going to look at a few examples of finding the derivative of a function which includes an absolute value. So for this first example, we're given that f of x equals the absolute value of x squared minus 3x minus 10 plus 1. Let's find the second derivative of this function. Well, to find the second derivative, we'll have to find the first derivative. To find the first derivative, it sure would help if we could rewrite this function, which includes an absolute value, as a piecewise function, which is exactly what we're going to do. So, we need to make a sign chart for the argument. The argument is x squared minus 3x minus 10. Let's make a sign chart for the argument. Here is a sign chart. Here is the argument, x squared minus 3x minus 10. We need to find the zeros. So it helps to see that x squared minus 3x minus 10 equals 0. This quadratic can be factored into x. And an x, let's see, I need to pick two numbers that multiply together to be negative 10, and that will have a sum or a difference of negative 3. I think the values that will do that will be, how about x plus 2 and x minus 5. So the quantity x plus 2 times the quantity x minus 5 equals 0, means that x could be negative 2 or x could be 5. Either of those values of x are zeros for the argument, and we should include them on the sign chart. So we have negative 2 and 5 going on the sign chart. This is creating three zones. We need to determine the sign of the argument on these three zones. Just to speed things up, the argument is a quadratic function. We know what the graph of a quadratic function looks like. Looks like a parabola, and we know where these zeros are. So the graph is doing something like this. So it starts off positive, it's negative in the middle, and then it'll be positive. So we have positive, negative, and positive on our sign chart. Okay, now that we have that sign chart, we can use that to rewrite this function as a piecewise function. That's going to look like this. F of x is equal to the piecewise function with three pieces for the three zones. The first zone for values of x less than negative 2 is positive, so that's just the regular argument. So that'll be x squared minus 3x minus 10 and then plus 1. This is for values of x that are less than or equal to negative 2. The middle zone between negative 2 and 5 is negative. It's a negative zone, and so we'll take the opposite of the argument. So the opposite of the argument is negative the quantity x squared minus 3x minus 10 and then plus 1. These are for values of x that are between negative 2 and 5. The third zone is a positive zone, so it's the regular argument again. So we have x squared minus 3x minus 10. There's that plus 1. And these are for values of x that are greater than or equal to 5. This is good work. Let's simplify what we have so we have the nicest version of our piecewise function. F of x is the piecewise function. Here we just have to combine the negative 10 and the 1. So this will be x squared minus 3x. Negative 10 plus 1 is negative 9 when x is less than or equal to negative 2. Here we'll distribute this negative on the outside, so it'll be a negative x squared, positive 3x, and a positive 10. Then we'll have to add the 1, so positive 10 and 1 is 11, so we'll end up with negative x squared plus 3x plus 11 when x is between negative 2 and 5. And the third zone, being positive, uses the same rule as the first zone. So we have x squared minus 3x minus 9 whenever x is greater than or equal to 5. Good. We now have a nice piecewise function to represent the function we were given. Now we can find the first derivative. The first derivative is found by finding the derivative of each piece of the piecewise function. So the derivative of f of x will be the derivative of the first piece, which is 2x minus 3 when x is less than or equal to negative 2. It'll be negative 2x plus 3 when we're between negative 2 and 5. And it will be 2x minus 3 when the x's are greater than or equal to 5. We're almost there. Remember, the goal was to find the second derivative. So, just to give ourselves a little more room, the second derivative is found by taking the derivative of the first derivative. So here we go. The second derivative will be this piecewise function, and we'll take the derivative of each piece above. So this will be, so the derivative of 2x minus 3 is 2, and this is for x that's less than or equal to negative 2. The derivative of negative 2x plus 3 is negative 2. That's for values of x between negative 2 and 5. And the derivative of 2x minus 3 is 2 whenever x is greater than or equal to 5. There we just found the second derivative.